All right, cool. Hello, everyone. I'm here to talk about this sort of obscure technology called Docker that nobody's interested in. So without further ado, so my name is Alexis Lê-Quôc. I checked actually in the app. There was some weird accent on my name, but I'm the CTO of Datadog, and what Datadog does is monitoring on cloud infrastructures. So we've been monitoring containers since before Docker was Docker, and I just, throughout the presentation, I'll explain kind of what we've learned, what interesting things about Docker in terms of monitoring. So Datadog is a monitoring service. It is made for the cloud, just like, it's basically made for you. And by made for the cloud, I mean something that really reacts naturally to having instances come and go, elastic workloads, so something that's modern. And with modern applications, when you want to monitor them effectively, you have to essentially aggregate a lot of data. So what Datadog does on top of that, it aggregates CloudWatch metrics and metrics from a lot of different applications like databases, app servers, and so on, and Docker, among one of them. And we've been supporting Docker since 1.0. So since Docker is 1.0, we've had sort of a native integration and native support. Before that, we'd support LXC, but that's somewhat of a different story. So what are my goals for this presentation? Mainly, I want to convey three things. I want to present key Docker metrics, and I'm sure you guys are interested in out of all the metrics that are out there, which are the ones that are interesting. I want to explain also, or present or introduce the impact that introducing Docker in your production environment will have on your operations. It's non-trivial, and that's what I'm here to talk about. And ultimately, I want you to rethink monitoring of containers. We'll see that it changes the game a little bit, and I want to explain why. And of course, how am I going to do that? I'll start with a very short introduction to containers because it's Docker. It's very popular, so I'm not here to do a 101 on Docker, but I want to sort of briefly introduce them and then sort of share with you some of the patterns or some of the numbers, some of the things we've seen from our customers running Docker on AWS. Then from there, we'll proceed to go into key Docker metrics, some things that you'll be able to get out of your Docker deployment. And we will then dive into the operational complexity that Docker is going to add to your environment. And finally, I'll basically give you the secret sauce on how to do it effectively. So please stay until the end if you want to know the ending. I'll give you a brief demo in the end as well. So, brief history of Docker and containers. So containers in a nutshell, what are containers? They've been around for a while, but they're essentially sort of lightweight virtual machines. So they go by names of jails, zones, C groups, depending on the OS. They're nice because they obviously have some of the attributes of fully virtualized machines without the overhead. Initially, it was mostly used for isolation, like security, like jails. But Docker more recently, and I think this is at least for me, the key point is it's emerged because it solves a very specific problem, which is dependency hell. And I think you'll recognize what it is. I've lived in dependency hell for a long time, and I think a lot of people do. And that's why you guys are looking into Docker. So back in the day, when computing was kind of not getting started, but maybe 20 years ago, roughly, we had 8.0. So 8.0, really what it symbolizes is it's a single binary. So you write your code, you compile it, you have one binary, you run it, you can run it from any machine, and it works. The problem there is that memory was not very optimized, so you'd have a lot of binaries that would gobble up memory, and back then memory was very expensive, so people thought, hey, let's introduce shared libraries. So now we have one binary that has just its what makes it specific, and it relies on external libraries to do sort of the rest of its work. And so the game there is you have a bunch of binaries that share common libraries, and that reduces basically memory footprint. So that made a lot of sense when computers had a meg of RAM or a couple of megs. Now it's obviously a lot less relevant. But still, that's how we've built software for the past 25 years, roughly. So once you start having a lot of shared libraries, the next thing you do is like, okay, now how do I manage all this stuff? And so you do what distributions did, which is you invent a package format, and then you have like complex rules that say, if I have this package and that package, then I can install the third package. So all these dependency rules, which presented a couple of problems. The first problem is that if you're doing sort of modern development, you often find yourselves in the situation where the distribution that you're running has really an antiquated package, say if you're Python, Ruby, and so on and so forth, and you're like, oh my God, I can't run on this 2-year-old thing, I need the latest, greatest, so that's the first problem. And the second problem is, to solve this problem, what you do is you end up like carving out, you're reinstalling your interpreter, your Python, you sort of work around the whole package. And so at that point, you start to have a lot of mess. So then what people figured out is like, well, let's make this easier. Let's package all the dependencies together into one nice directory, and something called Omnibus, for instance, lets you do that. And it's good, it's better, it's working around packages, but it's still work. It's still if you want to put an Omnibus sort of package together, you have to do some work. So kind of Docker arrived there as in, hey, let's forget about dependency hell. I'm going to give you one thing that you can install whatever you want in it, and then it has no dependency whatsoever on the underlying system. So that's how we got out of dependency hell. Now, the funny thing is that it looks a lot like a single binary that we had 25 years ago. Now, I'll push this a little bit further. So if you think about a container, you can look at different dimensions. So, and how does a container compare to a process or to a machine? And so the point I'm trying to make is a container is kind of a hybrid between a process and a machine. So it's a hybrid on a couple of points. If you look at a process, so it has a few things. It has source code that defines how it's built. It has the actual binary code itself in the .text here. And when you run it, it has a PID. When you have a host, it usually has some kind of recipe chef or Puppet module or a Kickstart file that tells it how the host is built. It has kind of the full distribution on files that basically is the host materialized on disk. And then when it runs, the host has a host name. And so the container is kind of in between because it has a Docker file that explains how to build the container. It has a materialization on disk. This is the virlib Docker thing, and it has a name or an ID. Now, the interesting thing about this is that this hybrid thing is you can, depending on what you do or day to day, you can look at it at a container as either more like a process or like a host. Case in point, if your day-to-day job is writing software, so you're a software engineer, more likely than not you'll consider a container as more like a process. So it has something that, yeah, I build it, or more like a binary. I build my binary and I ship it and it runs. If you're in operations, conversely, you'll tend to more consider Docker container as a host. It's like it has a host, some kind of a host name, and it has an ID, you can address it. It runs fairly autonomously and so on. So what we'll see is that the different perspective that containers present has a tremendous impact on operations. So now that I've kind of gone through a little history and how containers can be perceived, I wanted to share with you some other things we've seen, so practical things we've seen running Docker in AWS. So very quickly, a number of the use cases we've seen are anything around continuous integration. And the reason why you want to use Docker for continuous integration is very obvious, is because you get out of dependency hell, because you have dependencies are nicely managed. You don't go crazy with packaging compatibilities. The supremely good thing about it is that you put your Docker file, you build your container, and you take it from dev, from your laptop, all the way to production. It basically runs, which is something that's been the holy grail of computing since since before Java, I guess. And that's what makes it super interesting. Also, it has a very Git-like workflow, so it feels very natural to use. So that's one use case, continuous integration. Second use case that we see a lot is continuous delivery. So that's slightly different. It's like now I have a fleet of containers. I have a bunch of stateless components, for instance, web workers, video encoders, and so on. And these stateless components make excellent cases to run Docker because you build them, you ship them, and they run on their own. Not so good, Docker, not so good for data stores because it's just not the right fit. In this case, if you want something that's sort of nicely managed RDS, I think as one example is a better fit. So that's kind of the use case we've seen from our customers using Docker. So a couple of questions that I asked myself when I was putting together this presentation is, well, out of there, what kind of instance types do people use? So this is from October, from sometime last month. This is on a reasonably small sample of our total sort of population of customers, and probably because my interpretation is that Docker is still fairly new, and people are sort of getting dipping their toes and getting their feet wet and pushing a little bit, maybe in CI, maybe a little bit in production, but not full-blown in production. There are exceptions, of course, but that's how I see it. So the numbers that we can see here is that 60% of all Docker containers run on one of these three instance types, C3 to XL, M3 medium, M3 large. And then the rest is, so M3X large, and then M1 large, and the rest is 20%. So I think it makes sense because kind of M3, C3 is obviously more modern, and it's kind of a good deal in terms of compute per dollar. And a lot of the use cases, around if you're doing video encoding, if you're doing serving web, or you need CPU. And so I was a little bit surprised initially to not see like these gigantic machines with like R3s with a lot of memory. And so my interpretation there is that I think containers, right now we're still trying to figure out, and it makes sense more on a compute perspective and less so on sort of the RAM perspective. So they're more CPU bound than RAM bound. So that's the first observation that I was able to extract from seeing what our customers use. Second thing is number of containers per instance. So this is excluding sort of continuous integration farms because they kind of skewed the numbers. But on the population we have about 5 containers on average per instance, which of course is highly dependent on workload, but come to think of it, it's not that many. But again, I think it's really just the beginning. So I expect to see a lot more density, a lot higher density, even on average, on containers out there, on instances, per instance. So many more than 5 containers per instance. Now, the one thing I didn't mention in the data is that we see the maximum we've seen at a reasonable level is about 12. So it's 5 to 12, so roughly 10. Between 5 and 10 containers per instance. So that we have people running 100 containers per instance, but that's not the majority, and that's an interesting. So keep that number 5 in mind because it'll come back. It'll be useful. So with that, let's dive into key Docker metrics. So Docker, being something like a virtual machine, consumes one of these 4 things, usually all 4. Consumes memory, consumes CPU, consumes I/O, and consumes network. So it's only natural that kind of Docker metrics will typically cover all 4 things. Now I want to say there are maybe 50 or 100 different Docker metrics. I think I narrowed down to less than 10 that matter. That doesn't mean that the rest is not useful, but these are the ones I think about. So in terms of memory, for instance, the ones that I think personally are useful and that we see our customers use, it's anything around sort of the page faults, mainly because it indicates some kind of disk activity, and disk is slow, so you want to avoid that. Something around resident set size, which is how much RAM does your container actually use. This is mostly, this is important because if you have obviously if you have containers that take too much RAM, then you'll end up swapping, and that's bad, just because even on SSD, swapping is suboptimal. And then swap, obviously, is swap is swap. So you want to avoid swapping at all. A lot of instances have swap disabled, so that sort of makes the last metric maybe less interesting. But so in terms of memory, I think if you keep these 4 in mind, that's kind of, you're pretty much covered. The rest is a lot more sort of detailed and not so actionable in my mind. CPU is very simple. It's like, so Docker, it measures amount of CPU that it uses to run whatever you want your container to run. And then you can also measure how much time is spent in system calls. So that's pretty similar to what you do if you run like top or something. It's very similar. I/O important, though. Again, I think we've seen less, not a ton of I/O intensive containers, out there. Mostly seen compute intensive, so compute and memory intensive. Really, 2 metrics that I think make sense. So the amount of I/O that you're actually doing, because I/O is often or usually bottleneck, and then a measure of saturation of I/O. So the second one, I/O queued, which is how many I/O operations essentially are waiting to be processed. So the first one, service bytes, it's just a representation. I read the megasecond for 5 minutes. So it's neither good nor bad. It really depends on your workload. The second one, though, is much more important. And if you have a lot of it's like EBS. If you have a lot of queued operations, it means you're basically stalling processing because I/O is dragging you down. Network is in a sense, very similar to I/O, except you have slightly different measure of, so you measure more errors than saturation, but you can measure how many errors you get and how many packets you drop and then how many network transactions, network traffic you have. So these are kind of in 3 to, about 10 metrics for Docker that makes sense, that are, I think, the critical ones to watch. Now, how do you collect them? You can use, Datadog provides an agent for that, but also you can use something that in the open source world called CAdvisor that'll collect automatically metrics for Docker. So that kind of gives this quick walkthrough of all the metrics. Now, let's look at the impact on, which is, I think, also why you're here is you have these questions. All right, we're going to roll out Docker. It's great. It has a lot of benefits for our developers. It makes our workflow a lot simpler. What's ahead of us when we do that? So it's going to get complicated. So the reason for that is it's going to get a lot, many more moving parts. The reason for that is 15 years ago on the left side, this was your typical stack: hardware, OS, some off-the-shelf thing, G2E container, database, whatever, and then your app that sits on top of it. And that's pretty much it. And you have a bunch of those in the data center, and that's it. Comes virtualization in EC2, you start adding a little bit more complexity because now per piece of hardware you have more VMs, so you sort of slide in the hypervisor, and then that becomes a little bit more complex. I think I would wager that your operations have changed since you've moved to EC2. If somebody disagrees, please let me know. But so what I'm essentially saying is that it's going to change again when you introduce containers. So when you introduce containers, you're basically slicing further. So you're per VM, per EC2 instance, you add containers. So now you have a container that contains itself an off-the-shelf application, that's the O, and that contains that itself serve an application, that's the A. So you have a lot more of those. So now, if you remember that you have on average 5 containers per instance, that's based on data from October on data set I looked at. Sort of at first blush, it looks like you're going to have n times, so 5 times many more hosts to manage, and that's going to have a direct effect on provisioning, which is how do you build containers and configuration, how do you pass configuration to containers, orchestration. How do you decide where containers get run, when they get run, and finally monitoring, which is really, how do you make sure the containers run properly? And that's the last part. While all four sort of aspects are very interesting in themselves, that's really the last one I want to talk about, monitoring. So let's look at sort of monitoring currently as it stands. So you have one instance on EC2 that generates about 10 CloudWatch metrics. You have one OS running on that inside that instance that generates about 100 metrics. You have one container that, that's between 10 important metrics, but really total it generates about 50 metrics. And then you have one off-the-shelf application running inside the container, that's another 50 metrics. So you have right there about 160 metrics that just per container. If you want to look at everything from the top to the bottom, you have 160 metrics. Let's say you have 100 instances, so now you have 500 containers. That's only assuming 5 containers per instance. So you can do the math, which I'll let you do in your head. But if you have 160 metrics per instance, you add 5 containers per instance, you have 400. Not everything, it's not directly near, but you have about 410 metrics per instance. So if you had 100 instance, you're now at 41,000 metrics. So that's an order of magnitude more than before. And so just get prepared for that. But that's the easy part. The hard part is this. If you look at your half-life of your fleet, your EC2 fleet, so by half-life, I mean the median uptime of your EC2 fleet. I don't have numbers for this, but this is what we've observed, and I think this is how people use EC2. The median uptime, which means really roughly half of the machines die before that time. On EC2 is sometimes hours, days, or month. By that I mean you're going to have instances that you run for a couple of hours, you're going to have instances you run for a couple of days, and you're going to have instances that you run forever, for at least months, if not years. For containers, it's drastically faster. Containers typically, you'll kick one for a minute and then it'll do its thing and just go away. Maybe an hour, maybe days, but it's very unlikely that it's going to hang. You'll have containers, the same containers, like lying around and doing its thing for months and months and months. And there's a couple of reasons for that. One is with sort of hub-based provisioning where you can Docker file, build, Docker build, you can start generating images every day. And so these images have to be deployed, and so what that means is you have a really high churn of your container. And the second thing that's going to make things hard is orchestration, because now as you deploy containers in production, the next questions you're going to have is all right, well, how do I assign when, where do I decide, where do I put my containers? Who decides where they're running? And so you have these cool tools like Mesos, Kubernetes, Fleet that kind of automate that and take a very different approach that say, don't worry about that. Just tell me what conditions, what constraints you want to run the containers, and I'll take care of it. And so that's great because you can say, well, I want 5 containers per instance, per zone at any given time of this particular type. And if one of them crashes, start a new one. It's very much like the auto-scaling group idea. The bad thing is that this is completely automated. So things will just come and go, come and go, come and go all the time. And so from an operations perspective, it becomes really non-trivial. So it's going to be a lot more and a lot faster. That's essentially what what I'm conveying here. Not everything. So it's not necessarily an oblique picture. But what I want to say and what I want to stress is, if you're thinking about containers, if you're thinking about monitoring your containers like you're monitoring more hosts, it's going to be hard. This is the picture. In case you're curious, you could maybe read this as the Earth at the center. So back in the ancient times, people thought, well, the Earth is the center of the universe, and they were trying to do astronomy with the Earth at the center of the universe. So you have this complex gyration and epicycles, and it got out of hand really quickly. And so that's kind of, if you think about monitoring Docker containers like you're monitoring new instances, that's kind of what you're getting yourself into. Or you could say, you know what, I can monitor OS and hypervisor, I can monitor the app, I'll just let the containers be. that's not great because right, you're going to have a huge gap in your monitoring. So you're like, oh, well, I can't see anything. So that's obviously not where you want to be. But if you want to, if you still think of monitoring Docker containers like they're like single machines, it's going to be a lot of pain. It's going to be super fast. I mean, things will come and go. Your monitoring system will go crazy. It'll alert, hey, this container died. Hey, this container died. Hey, this container died. Just because the scheduler, the orchestrator is just moving stuff around, and it's normal. You don't need to be alerted. Now, with all that said, is this the end of the world? So obviously no. I wanted to share a few ideas that we've had, and I think you can get the problem under control. It does though require a new approach to container monitoring. This picture, as a contrast to the previous one, I was like all these complex cycles. This is what happens when Copernicus put the sun at the center of the universe. Everything became a lot more very clear, very simple, and that's kind of. I don't have the pretension to do what Copernicus did, but I think that's kind of the mental shift that I'm proposing as to you in the audience. So the secret sauce is these two words, layers and tags. So it's very simple, really. Layers means this. Layers means that you want to monitor everything. So you don't want a gap just because it's not acceptable to run stuff in production and there's half of the stuff you can't see. It's just not acceptable. So you want to monitor everything. And when you think about the tools you have at your disposal, so you can do it. So what I'm saying is you can do it. You have to make sure that, so CloudWatch will cover the hypervisor, your APM or application performance monitor will cover the top, but your infrastructure monitor has to cover the middle. It has to understand containers. So if you care about the app throughput, the APM will probably tell you about, oh, this is how many successful web queries I'm able to process. If you care about sort of raw resources from CloudWatch, from the hypervisor, CloudWatch will provide. If you care about file system, Docker metrics, database queries, web requests, and so on, your monitoring should be able to provide that. So you really want to have a very layered approach to monitoring. So you want to be able to access all the metrics. So metrics from all the layers like easily. Because you want to be able to compare them. So that means you want to be able to have like CloudWatch metrics, OS metrics, Docker metrics, everything in one place, all in one shared timeline, so that you can put the picture together. If your monitoring does not cover all the layers, it's going to be painful. Very obviously. Just because you'll just see either the top level stuff say, oh, the app is not performing well, and be like, okay, well, I don't know, I can't see what's beneath. Or if you look just at the bottom, say, hey, this machine is performing, it's 100% CPU utilization. It's bad, good, I don't know. It depends whether it's expected or not. So layers is really, you want to be able to look at everything in one shot, and that's really important. The second thing is, this is really, I should say the key thing is tags. And the good news, and that's kind of for me it was kind of the leap, or not the leap, but the aha moment where it's like, oh yeah, we can use this. This is going to be super useful. So tags, the good news, who doesn't know what tags are in Amazon parlance? Okay, everybody knows, cool. So you use them already, of course. Your machines are tagged by AZ. They have a security group. You can add your own. There's an instance type. So there's a lot of properties that you can have. And so when you think about that, it lets you think about monitoring just like you think about auto-scaling groups. So monitoring is not saying, I need to monitor this machine, that machine, that machine, that machine, and that machine. Monitoring is really saying, I want to monitor all the machines that have a given property, or all the processes that are a given property, or all the services that have a given property. And that property is based on tags. So I'm going to give you a few examples. One of them is, for instance, let's say you deploy Docker, it runs your web tier. So effective monitoring, if you don't want to go crazy, you want to be able to monitor like so. You want to express your monitoring in saying, I want to monitor all the Docker containers running a given image, image web in region US West 2 across all AZs and make sure that resident set size is less than 1 gig on a C3XL. I've highlighted the tags here. It's pretty clear, right? One tag is it's a Docker, the image is web. Another tag is region of the EC2 instance is US West 2. Another tag is availability zone can be US West 2, A, B, C, D, E. Last tag is instance type has to be C3.xl. So do you see how powerful this can be? Because that means that, look, you can CloudFormation 100 new instances. This doesn't change. The query is still valid. It means that it adapts to your infrastructure. You can spin up, move from 5 instances per containers running web to 100 instances, or running containers, per instance, running web. It doesn't change. This remains true, and this is how you express your monitoring. And this is how you can effectively monitor Docker containers. And I'll give you an example, so it doesn't just remain, in abstract. But the cool thing is then you can get more sophisticated because then you can say, well, I want to monitor all Docker instances running that use more than 1.5 times the average RSS, I missed a word here, on all the machines that are C3XLs. So this then lets you become a lot more sophisticated in how you monitor. And I posit and I submit to you that the only way you can monitor Docker effectively is to be able to do this, because otherwise you're going to go crazy real fast. Okay, so now the good news is you've been through that already. In a way, you've been through that transformation already. When EC2 was introduced, the basic assumption or the basic premise was like, we give you a server, you don't know where it is, you don't know what rack it is, like things that we thought were very important to us, that completely went away. So yeah, dude, where's my server? It's like, I don't know, and frankly, I don't care which server is running, where the physical server where my instance is running, I don't care. So it's exactly the same thing for the container. It's like, it doesn't matter where, which machine, which host your container is running, because it's here one day or 1 minute, it's somewhere else another minute. What you care about is really, you want to be able to express your monitoring as, I want to monitor all the containers that have a given property, and or a set of properties. And that's really key to not going crazy with Docker in production. So if your monitoring is not tag-based, it's going to be painful. And I want to show you a little bit of a demo. So how do I do that? Hopefully it works. Yes, no. Sorry. How do we get the browser projected here? Yes, I found it. Okay. So this is what I did. I wanted to have an actual real-life example, an example. So these are real containers. These are containers I spun up. So what I did is I CloudFormation a bunch of CoreOS instances, and whereby I decided to roll out a bunch of containers. So I use, as an example, I use our stuff because I know it well, but the idea remains the same if you use something else. So we have like an agent that you run as a container, and then you can see it gave me, so I have 66 running containers, I have running on 23 instances, and you can see throughout the day what I did. I started a bunch, that's the containers, it's kind of remained flat overnight, and then this morning I started a bunch of new containers. So that's kind of the setup of of this example. The bottom half is kind of trying to show you using different layers. So I looked at CPU consumed by by containers, ultimately consumed by containers, but I wanted to see what it looked like at different layers. So you can use, as I mentioned, at the lowest layer, you can use CloudWatch to get EC2 CPU utilization. So you can see that I have a bunch of machines that are either maxed out or kind of idle, and they go up or down. I did the same by getting the same metrics. So this little agent container thing collects everything, mostly from the host. So the host that runs all the containers. And so that gave me, I don't know, you can see there's a bunch of machines that are maxed out 100%. There's a bunch that are kind of in the middle. There's a bunch that are completely idle. And I also looked at the same metric, same idea from inside the container. So in this case, I looked at, so the user, technically it's the user G-fees consumed by the container, which is why you can go over 100%, but that's the idea. So that starts to give me, at least I have a good sense of, or at least I have a sense of, well, what does it look like at the lowest level? What does it look like at the, the slightly higher layer, and so on. So that's how I layer monitoring to have access to everything. And then I wanted to look at, so start using tags within the layers. So again, I looked at metrics coming from CloudWatch, split by, so one type of instance versus another type of instance. So you could see that initially when I had CloudWatch EC2 utilization across everything, I had a bunch of maxed out, a bunch at the bottom. Turns out it's not completely arbitrary. It's very clearly split by type. So EC2 instance C3X large, completely idle. My M3 mediums have a bunch of instances maxed out and a few that are almost idle. Then I kind of did the same thing. Now the interesting thing is and before I do that, the query that I was talking about is, so if I wanted to get the CPU utilization of all EC2 instances of zone 2A, this is the kind of query that expresses that. It's something that basically says, this is, I care about CPU utilization in zone 2 for M3 mediums. That gives me the graph on the left. And the same thing for Docker metrics. We have utilization of containers. So I care about the metric Docker CPU user, West zone US West 2, type C3X large, I think in this case. So you can see an example of the queries, because nowhere here do I talk about a machine or instance ID or anything. I only care about where, a set of tags, a set of properties, and then kind of magic happens, and it does the rest. So another way to look at it, I kind of dove a little bit deeper, is now you can focus on a given image. So again, I care only about the containers that run an image of a particular type, and I want to, how do I query, how do I monitor it? So I can use the following queries. I say I care about Docker CPU user. It runs this image, and I want to break it by zone. So again, something that was not at all visible initially is that by zone, there's one zone that's super busy and a zone that's kind of medium busy, and that's the zone that's completely idle. And that stuff is not visible if you're looking just at the host, at the instance. Same thing for the, if I wanted to get a different view, so even in a given zone, US West 2B, that's the query, the three queries at the bottom. I want a minimum, the maximum, the average. So I want to see the distribution of how much CPU containers are consuming in a given zone running a given image. So that's the power of queries. And what I submit to you is that you basically, however you do it, you have to be able to express monitoring like that. So it won't work to monitor things host by host. All right, so move that out of the way. Okay, so we're basically getting to to the end of the presentation. So I have the takeaways I think which I hope I've been able to convey is that Docker will increase your operational complexity by an order of magnitude, and that's 5 containers per instance. That's going to be, and then the containers move around fast, and then they come and go super fast. That'll drive you crazy from an operational standpoint unless you can have monitoring that kind of looks at all the layers at once, and something where monitoring where you can express your what you care about, what you want to monitor with queries and tags, not by just pointing at individual hosts. Thank you very much.